What measures of central tendency and spread are best for a skewed distribution? Okay, the median, the IQR, and the range. If it's symmetric, you would do the mean and the standard deviation. The median and the IQR are resistant, so they won't change much if you put a big outlier in there. But we also want to include the range because we want them to know there was an outlier. So if you did our class's birthdays or class's ages with my birth date, the median and the IQR would really tell you what's going on with all of you, but then having a large range lets the people looking at the data know, hey, there's also an outlier in there somewhere. Okay? So these two are measures of spread, and this is measure of center. Next, in your own words, explain what standard deviation measures. I'll go over this some more next week, but it's the average distance from the mean. The standard deviation formula is the square root of the sum of every value minus the average squared divided by the total. You're adding up all of the distances and then dividing. That's like adding up all the values and dividing by the total, that's the average. And then we take the square root to basically undo the fact that we squared already. So it's kind of the average distance you are away from the mean. Here, find the arithmetic average, i.e. the average you know. Add them all up and divide by 5, right? This plus this plus this plus this plus this is 9. That's what this means. The sum of xi means add up all of the values and divide by the total number of values. Okay, and it turns out that this is a skewed distribution if you looked at it, because if this is the average, if I subtracted the standard deviation, which you haven't found yet, even one standard deviation below average makes you into the negatives. How do you do negative homework, right? So that's a side note. This table is to help you do standard deviation. You don't have to do it this way, but that's what it's trying to help you do. It says, okay, here are all of our values. In order to find standard deviation, we need to take every value and subtract the average. So 0 minus 1.8 is negative 1.8. And then if you squared it, you get 3.24. So all of these, this is just the distance from average, and then we square it. We square it to get rid of the negative, because if you added these up, the negatives and the positives would cancel out. Now, this is every value minus the average squared. So you would add them up, and that is the top part of your equation. You could then plug it into your formula, okay? This right here is every value minus the average squared, added up. So that's where the 14.8 goes. Divided by, this was a sample right here. It was a sample of 5 students. So we have to use the sample standard deviation, which is n minus 1. And we do that because it makes our answer a little bigger. We want our answer to be bigger to account for any error you made by taking a sample. Now, you need to know how to show the work by hand? Yes. Would I be okay if you put this in the calculator? Yes. So let me show you how to do that one more time. So it can come out of the calculator. It's right here, sample 1.92. You could have done this. You don't have to use a table. You could have said first score 0 minus the average squared plus 1 minus the average squared plus add them all up, get your total, and then divide by 4 and take the square root. You didn't have to actually use the table. Any questions on that? All right, so here now for today, our goal is to be able to do the same thing but with group data. Find the mean, the standard deviation, and then we're going to talk about the weighted mean, which is what we did in 1030. So these are the formula for group data. I'm going to come back to them because it's not super important that you can read it, just that you can do it. So here we go. What if instead of having a sample, you conducted a census of all 12th grade students at Hillcrest High School and asked them how many hours of homework they did the previous week? Okay, so I don't have the raw data, but I talked to 430 kids. 47 of them did homework between 0 up to but not including 3 hours for that week. Okay, 116 had 3 up to but not including 6 hours of homework, so on and so forth. I don't know the actual data. Could be that all 47 kids in here did 1 hour of homework. I don't know, nobody gave me the data. So we have to estimate. So we need the class midpoint. Well guys, isn't this basically 0 up to 3? What's halfway in between 0 and 3? 1.5. So here's what your book says. It says the class midpoint is the sum of the consecutive lower class limits divided by 2. I'm just going to keep referring to the vocab out of the book. So what that means is you wouldn't want to do 2.99 because that's basically 3. So it means this one plus this one divided by 2, the middle is 1.5. 3 plus 6 divided by 2, we'll say the middle is 4.5. And what we're saying is, since we don't know what all 47 kids had, but we're trying to estimate their average, we're going to say all 47 of these kids did 1.5 hours of homework. That's going to be my guess, right in the middle. Okay? Now, how do you find the average? Isn't the average adding up all the data and dividing by the total? So you could add up 1.5 plus 1.5 plus 1.5 plus 1.5 all the way up to 47 times, plus this one, plus this one, plus this one. But a smart person is going to do what they know, which is, doesn't multiplication make adding faster? So you're going to take and say, I had a difference of I had a homework of 1.5, but that happened for 47 kids. So I'm going to multiply these two together, and that would be my value. 116 kids supposedly had 4.5 hours of homework. So instead of adding up 4.5 116 times, you just multiply them and get that. And then if you add all of them, the total is this. Okay, so that is the sum, this means sum, of every value times how often it happened. That's just adding up all the values. Okay, well, if you look at their formula for finding the average, we're going to find the population average. It's saying find the sum of all the values and divide it by the sum of the frequencies. The sum of the frequencies is just how many kids did we survey, right? Here's a frequency, here's a frequency. We surveyed 430 kids. So it's saying add up all their homework and divide by 430. It's the same thing you were already doing. You're just using multiplication to make it faster. If you did that, you would get this. An average of 6.46. Now here again, you need to know how to use the formula, but I am 100% okay if you take the whole homework and you do it in your calculator. Stat, edit. I don't know all the data, so I'm going to let all of these be my data points. 1.5 hours, 4.5 hours, 7.5 hours, 10.5 hours of homework. And then I'm going to say, well, this happened 47 times, 116 times, 206 times, 61 times. And then you could do the same thing, stat, calculate, one variable stats. Still, the only thing that's varying is the amount of homework the kids are doing. So your data is in list 1. How often it happened is in list 2. And then you can say calculate. Oh, look, there's your mean. And in a minute, we're going to find standard deviation by hand. But again, I don't care. On your homework, here it is. Okay, that's the one for population, and that's the one for sample. I will qualify on your homework and say, for section 3.2, they want you to do it with the formula 2 different ways. Do that a couple times so you know how. And then the rest of it, just put it in the calculator. I don't care. You can also use the calculator for this on your homework. So let me show you that quickly. Again, in Canvas, if you fish around, there are tutorials on how to use Math Excel StatCrunch. So fish around. There's so much on there that I've given you. That fish around and find it if you don't know how to use StatCrunch. Or, okay, it's 2021. Google, how do I do this on Math Excel StatCrunch? And I am sure it will come up on a video or a document. Okay, use your resources. Sorry, the smart person would have had this up already. All right, so let's say I'm going to go to this homework because 3.3 is group data. And having to mess with group data, you have to read how to do it. Well, I guess I'll show you. Which one did I pick? 3, 2, 3, 3. Doesn't matter. Who came in late? David? All right, I'm going to stop and let that think for a second. We're going to finish the notes for this next part, and then I'll come back. Okay? All right. We are going to do the standard deviation now in a table. And here's the formula. Why am I dividing by n? Yeah, they took a census. We have data from all of the 12th graders at Hillcrest High School. So that's the population of Hillcrest High School students. So I'm going to divide by n and not n minus 1. And I said n They're calling it the sum of the frequencies. Well, that's just n. Okay. All right, so this is this data set right here, the class midpoint. Here's our frequencies, and we know our average. Our average is 1.8. Our average is, that was the other problem, 6.46. So we're going to take our data, 1.5 minus 6.46, and we're left with this. So that's them subtracting them. Then I square it, and I know the square difference from 1.5 to the average is 24.6. Right here, this is this part of the formula. But that didn't happen for one student, that happened for 47 students. So I'm going to take this and multiply it by how often it happened. So this was this times that, and that's how I got 115628. Yes. Okay, so if we did that now, we know that we've done the yellow numbers times the pink numbers, the difference is squared times the frequency, and we're adding them up. So that's this value right here. This is my whole numerator, and I'm going to plug it into my formula. Divided by the total number of kids surveyed, and I did 430, not 429 because it was not a sample. Take the square root, and we estimate that the standard deviation is 2.56. I don't know that it's exactly 2.56 because I didn't have all the raw data, right? I let all 47 kids have a value of 1.5, but it's a decent estimate. And then again, once you can do this, here it is in your calculator. Population 2.56. Yes. So once you have it plugged in, stat, edit, your data is here, your frequency is here, and if you look at the bottom of your notes, there's a purple box with notes for this, so you don't have to write it down if you don't want. Stat, calculate, one variable stats. In fact, right here, here it is. I not only tell you how to do it in the 84, but here's how to do it in StatCrunch that I was trying to show you. So all of your notes will always have the purple box, whether or not I use my notes or Slick's. So then it says, press the stat button, calculate, select one variable stats. List 1 is where my data was. My frequency list is list 2. I'm so glad you asked about that because I know a bunch of kids didn't know that. And there's my standard deviation. Oh yeah. The basic thing is on the homework, do it once or twice by hand so you know how. And then just use a calculator. I don't care. Because what would you do in the real world?
Yeah, oh my God. Okay, that sounds good.
So on that note, let's look at StatCrunch now. Okay, I'm going to try to find, come on, a problem that I think might have some issues. Okay, so see how they have data? Even if they gave it to you in a frequency list, go to StatCrunch, and you can use this to do whatever you need. If they just give you a few pieces of data, like right here, I'd probably use my calculator, because that's what you get on the test. But some of the homework, they give you 50 pieces of data. Do not type that into your calculator. Use freaking StatCrunch and walk yourself through it. So, like here, if I wanted the summary statistics, I want it by columns. One variable stats, it's going to give me all of these statistics right here, the mean, the variance, blah, blah, blah. Again, there's instructions for this on Canvas. Hey, look, my mean is 0.86. My range is, it's got everything you need. And I am fine with that. Because the idea with statistics is not can you crunch the numbers, but then can you do something with them? Can you interpret them? Okay. All right. So again, your notes all have the purple boxes. This is how you stat crunch the binned data, the group data. All right. So now we need to talk about, what does that mean? How could we describe that distribution? So go ahead and try to draw a histogram for this data. So on the bottom I have 3, 6, 9, 12, because that was my cutoffs. My class width is 3, or my bin width is 3. And then when I look at it, how many students did homework between 0 and up to but not including 3 hours? 47. How many students did between 3 up to but not including 6 hours of homework? 116. And so that's how I made my chart. And then if I wanted to describe it using socks or sucks, well, what's the shape of this? Anybody want to volunteer? What's the shape of this? Thank you. Bell-shaped, symmetric. Don't say normal because we don't know. I left off, I put unimodal, but I should have also said bell-shaped or symmetric. That's a better answer. Okay. Are there outliers? Probably not, but I didn't check. What's the center? Well, it's fairly symmetric. So I'm going to list the mean, but it doesn't have to list the median as well. And then how spread out is this data? Well, I'm going to go ahead and list the standard deviation. Since it's symmetric, and that uses all the data points to talk about it. So we've now talked about how to find the mean and standard deviation of groups data. We don't have the raw data to look at. And then again, like anything else, we can make a histogram and comment on shape, center, spread, and unusual values. Can you use this data to infer information about the whole population of Hillcrest High Schools? What do you guys think? Can I use this data? I'm saying a yes and I'm saying a no. Why yes? So, and then why are you saying no? So, yeah. So the answer is yes, but really no. We don't have to infer anything. Inferring would be that I maybe just did a survey of you guys being seniors and then said that must be what's happening with all the seniors. But since my population was Hillcrest seniors, there is no inference. I know for a fact this is what happened with the seniors because I asked all of them. I surveyed all 403 seniors. Okay? All right. Next one. The weighted mean is the same as we did in 1030 when I made you do this stuff. Remember when I said you have 80% on your homework that's worth 30% of your grade, plus 70% of on your quizzes that are worth 40% of your grade. How much do you need to get on the final, which is worth 30% of your grade, to get a 90? Something like that, okay? That's what a weighted average is. We're going to do it but without percents. So again, here is the book formula. Let's just skip to the problem. Marissa just completed her first semester in college. She earned an A in her 4-hour stats course, a B in her 3-hour sociology course, an A in her 3-hour psych course, a C in her 5-hour computer programming course, and an A in her 1-hour drama course. Determine her grade point average. And this is exactly how we do yours. If you look at your report card that we mail home, it's in the bottom corner, our skill. Okay. We're going to say an A is worth 4 GPA points, a B is 3, a C is 2. All right, so for her, she got an A in her 4-hour stats course. Okay. This A comes from that she got an A for the stats course. Okay, this 4 right here was at a 4-hour stats course. Okay, she earned a B in her 3-hour sociology course. Okay, so this is her B. And then this is the fact that it was a 3-hour course. She got 3 credits. When we do it for you guys, for your semester grade, we'd put in 0.5. For your quarter grades, we put in 0.25. Okay, so then, again, quickly, she got an A in her 3-hour psych course. So the A is right there, but then it was 3 credit hours, and so on and so forth. If you multiplied all of those together, you would get 51. So she got 51 points out of a possible 16 credits that she took. So her GPA is 3.19. All right, so that is the rest of 3.3. All the purple boxes or blue, whatever color you want to call it, that's for your TEP, okay? And then don't forget the reading, and I'm telling you where you can find it, okay? All right, so now we're going to talk about 3.4, and we're going to look at these 2 objectives: determine and interpret z-scores and interpret in percentiles. Your warm-up used to be a quiz in class, which I gave you at home, so you didn't need to take that. Okay, so we're going to talk about z-scores, and I'd like to start with this. Suppose that a professional soccer team has the money to sign 1 additional player, and they are considering adding either a goalie or a forward. The goalie has a 90% save percentage, and the forward averages 1.2 goals per game. So it says, in this league, the typical goalie saves 86% of the shots with a standard deviation of 5%, while the typical forward scores 0.9 goals with a standard deviation of 0.2. The ones we're looking at to hire, okay, the goalie has a save rate of 90, and the forward, where is it, averages 1.2 goals a game. So all I've done there is take the data out of these 2 paragraphs and summarize it. Okay, the goalie is 4% higher than the average, right? This goalie is getting 90% of his saves, while the average goalie saves 86%. And the forward, he's making 1.2 goals on average, while the average forward makes 0.9. Who's better? You can't say that the goalie is better since 4 is bigger than 0.3, because we're talking number of goals versus percents, okay? So we have to standardize it. So we're going to use our z-scores, which we used last semester. For the goalie, okay, we take what he gets minus the average goalie, so how off is he from the average goalie, divided by the standard deviation. And then for the forward, we do the same thing. Okay, so the idea then is, who would we want to hire? The goalie or the forward? Who's better than their peers? The forward. He's 1.5 standard deviations better than all the other forwards in the league. Well, this guy isn't that much better than the other forwards, just a little bit. Okay, so we'd want to hire the forward. Now I want to go back to the top of this page and review how we did what we did with this last semester. What if we were looking at the weight of apples? Okay, and if you go out into a field, the average weight of an apple in this orchard is 12 ounces, plus or minus a half an ounce. okay? And I claim that it's normally distributed. So within 1 standard deviation is 68% of those apples in the orchard. Within 2 standard deviations is 95% of the apples in that orchard. And I could even draw a picture. Okay? And then what if the question is, what's the probability I go out in that orchard blindly and randomly pick an apple and weigh it? What's the probability that that apple will weigh more than 11.3 ounces? Well, what did we do last semester? We said, go to 11.3 on my curve, and we want this much or more. So we did normal CDF from 11.3 all the way up to infinity, for assuming apples can get really, 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 really big. And it turns out it's 0.912, or 92% of the apples in that orchard will weigh approximately 11.3 ounces or more. The only difference between that and what we're doing now is we could standardize. We could have put these values in the z-score formula and said, well, let's center it at 0. This is 1 standard deviation. This is 2. This is 3. And how did we use those z-scores last semester? What we would have done last semester is standardized 11.3. So we would have found a z-score. Turns out, right, the score minus the average divided by the standard deviation, turns out it has a negative 1.4 standard deviation. So it's negative 1 and almost a half standard deviations below average. We've taken off the units, so now we could look at the z-score table from last semester and we need negative 1.4. Negative 1.40. Our table tells us it's a probability of 0.0808. And I'm just going to round that to 0.08. Okay? What does that mean? The table said it's a probability of 0.08. Why doesn't that match, and what did we just get? Exactly. The table only goes to the left. So it gave you the probability of being negative 1.4 or to the left. So it gave you this 8%. You would have had to subtract that from 1 to get the answer of 92. Again, do I care if you use the table? Not at all. Just use the calculator. But I wanted to link this to what you did last semester because it'll show up. Any questions before I move on? All right. So, and then again, we could have done the same thing here and found the probability of having this good of a z-score, but I'm not going to worry about that. All right. Using standardized scores has many advantages. Since z-scores have no units, we can compare values that are measured on different scales with different units or from different populations. So for example, suppose that the distribution of male heights has a mean of 69 inches and a standard deviation of 3 inches. And the distribution of female heights has a mean of 64 and a standard deviation of 2.5. Who is taller relatively speaking? A male that's 65 inches tall or a female that is 60 inches tall? You can't just compare men and women because usually women are shorter than men based off of population heights. We want to know who's shorter compared to their gender. So just like we did with the goalies, I can take the dude score and subtract it from the average and divide it by the standard deviation. And I could do the same thing for the female. The guy is 1.3 standard deviations shorter than his peers. While the girl is 1.6 standard deviation shorter than the peers, who's shorter? The chick. Compared to all other girls, she's shorter than he is compared to all other boys. This very last thing, I'm going to put it up there and you can read it over if you want. You could also use that to solve for a value. And so this will be on the video. You can look at it, but it's not on your homework. We're not going to go over it. Okay? We're going to talk about percentiles. Percentiles are used to give the relative standing of an observation. Okay? So, if you are the 50th percentile on your ACT score, that means you scored the same score or better than 50% of your peers. Percentiles go to the left. It's percent, and the L is to the left of the cutoff. Can I scroll? Okay. So let's look at it based off of what you're probably dealing with recently. Your percentile ranking in ACT is a comparison of your ACT score with everyone else who took the test. Specifically, your percentile tells how many people you scored higher than in percent, the same or higher. The ACT will give you a percentile ranking for your composite score as well as for your 4 subject areas. And it changes every year because sometimes the tests are a little harder or a little easier. Okay? For example, if you get a 70th percentile, this means you scored the same or higher than 70% of test takers. It doesn't mean you got 70% of the questions correct. It just means 70% of the people you took the test with got your score or lower. So, if I looked at this, Harvey Husky earned a 28 on the math portion of the ACT. What is the percentile? So, you can get these for every year. He got a 28 on the math section. That would give him the 91st percentile. That means he scored as good or better than 91% of the other people that took this test. So, we talked about how to find z-scores, how to interpret percentiles. I added in all of that finding area under the curve. We'll talk about that later. But since you've seen it last semester, I thought it was a good place to link it. Now I need to talk about quartiles and IQRs, how to check for outliers, 5-number summary, and the box plot. So again, Tootsie Pop stuff from last semester. Okay? So these are all their steps for how to do all of this. We'll come back to it, but let's just look. This is nice and symmetric and bell-shaped. If that's the case, your box plot looks nice and symmetric and bell-shaped, and it's usually more condensed in the middle because you have more data in a smaller range. And then it gets more spread out as you go. Similarly, it might look like this if it is right skewed, and it might look something like this with a longer tail if it's left skewed. Okay? So, to the right is data from 2 different geographic regions and the percent change in growth over the previous 10 years. I totally made up that it's Utah and Salt Lake County. It is not. I don't know where it came from. Okay. Find the 5-number summary for each, create a box plot, and use them to compare the region's growth rates. So if I looked at Utah County, 5-number summary, okay, we want the middle number. So I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That must be the middle number because there's 9 on this side and 9 on this side. I just counted to the middle. That's my median. And then if you cut that in half, I have 4 here and 4 here. So my Q1 would have to be 10. And my Q3, I've got 4 here, would have to be 4. Now this is a split stem and leaf plot going from the smallest up, which is just freaking weird, but it was in your book, okay? And they're listed as percents. Notice the percent area here. So you should be able to do this by hand. Put all the numbers in order, find the middle number, and then the middles of the middles, okay? And how to do that, if you need help, is right here in steps, okay? But I am totally fine if you put the data in a calculator and crunch the numbers, okay? And if you did that, you'd get a minimum of 1, a Q1 of 4, a median of 8, a Q3 of 10, and a max of 12. Now we want to find the interquartile range. IQR is Q3 minus Q1. So 10 minus 4 is 6. The middle 50% of regions, of counties in, not counties, I don't know, part of Utah County, areas in Utah County, their population percent ranges by 6%. Okay? Now we want to see if there's an outlier. So the outlier formulas, which are right here for you, are Q1 minus 1.5 the IQR and Q3 plus 1.5 the IQR. So Q1 is 4 minus 1.5 is 6, that's negative 5. I suggest you're careful with that in your calculator or it will lie to you. And our upper value is 10 plus 1.5 the IQR. That means any number less than negative 5 is an outlier. We don't have one. Any value greater than 19 is an outlier. We don't have one. Okay? So we could do the same thing for region 2. And honestly, I just put the data in the calculator. Now, what I am going to make you do for just a minute, can you find the lower fence and the upper fence for outliers? Can you do this part for this data for Salt Lake County? When you have it, stand up. So our interquartile range was 17 because 27 minus 10, you plugged it in and you'd get negative 15.5 and 52.5. We do not have a lower outlier, but we do have some upper outliers, right? 61 right here is an outlier. It's bigger than 52.5. Now we're going to draw 2 box plots. So this is how I do it. I put a scale. It's the percent growth on the bottom. Okay. And going for the Utah County, I said the minimum is 1. Q1 is 4. Q2 is 8. Q3 was 10. And the max was 12. So that's my Utah County. I did the same thing for Salt Lake County. And I'm going to pause and let you copy this down before I talk. Just keep writing. I did the same thing for Salt Lake. Okay, I have a minimum of 3, a Q1 of 10, a median of 15, a Q3 of 27, and really my max goes all the way up here to 61. Okay? However, we want a modified box plot. This version that I have up here, if it went all the way out, this would just be a regular box plot. I'd like a modified box plot. So I'd say, well, anything bigger than 52.5, which is right here, that's an outlier. Do I actually put that on my graph? No. Okay, this should not be there. So what I do is I put a dot at 61, and then I go down to my next lowest number, which is 42, and that becomes my maximum. Okay? And then again, what do these boundaries mean? Well, what statisticians said was, here is the middle 50% of data, right here. Let's take 1 and a half of that, and anything above this value right here, that would be 1 and a half if I'd done better, is too high, and that makes it an outlier. Same thing with below. Let's take 1 and a half of that. Anything past here would be too low. Okay, so looking at that then, that's how you make a box plot and find the quartiles, everything. Now let's compare them quickly. A company that sells frozen pizza in stores to 4 markets in cities A, B, C, and D wants to examine the prices that the stores charge for pizza slices. To the right are their box plots comparing the data from a sample of stores in each market. Okay? Do the prices appear to be the same in the 4 markets? No, they don't look the same. Does the presence of outliers affect your overall conclusions about the prices of the 4 markets? Honestly, to me, no. Because what they're saying here is in market A, all of the pizza slices are a little less than $2 or a little more than $2. Okay? For whatever market B is, it really ranges. They're a little more than $2, all the way up to a little more than $3, or you could luck out and get one of the 3 cheap stores in that area. Okay? Overall, though, my conclusions when I look at it are going to be, if you want consistently cheap pizza, go to market A. Okay, yeah, could you get cheaper? Yes, but you'd have to luck out and hit one of the cheap stores. So the outliers didn't help me that much. Now, could you just Google that information? Yes. So, right? Okay, last but not least, sugar is a major ingredient in many breakfast cereals. The box plot and histogram to the right display the sugar content as a percentage of weight for 45 brands of cereal. Okay, what is the approximate median of the sugar content? Well, I'm going to look at the box plot. The median is right here, so a little under 25, and I have the real data, it's 24%. You don't want to try to get a median from the histogram. Sometimes you can, but this data is interesting. Okay, your median would have ended up being in here. It's hard to tell. Okay, what is the approximate age range of sugar contents in these cereal? Well, the range is the highest minus the lowest, and I happen to have the data. The highest was 65, the lowest was 1 gram, so 64. Describe the shape of this distribution. Any thoughts? It's not left skewed if you were, or right skewed if you were thinking about it. It wasn't that most of the data was here with some low ones. It's actually bimodal. If you look at it carefully, right? What this is all the healthy cereal. They have very low sugar content. And then this is the fun cereal. So it's bimodal. We've got almost 2 groups of data in there. And so most of the healthy cereals have a sugar content between 0 up to, but not including 10. While it looks like the middle amount for kids cereals or fun cereals, they have a median amount somewhere between 40 and 50 grams. So you can sometimes get a lot of information from a picture like that. Okay. All right, that is 3.4 and 3.5. You now have all of